Hi, and welcome to this tutorial on how to train your custom crop model using the World Serial system. Custom model training is done through a Jupyter notebook. Follow the links displayed here to get access to this notebook and get started on your own applications right away. Before we dive into the hands-on demo, let's first have a look at the generic workflow we'll be following throughout this session. We first select an area and season of interest for which we want to train a crop type model. Based on these criteria, we query the database of publicly available reference data, which contains a large collection of harmonized land cover and crop type samples from all over the world, along with the relevant Earth observation time series required for model training. For each resulting sample, we compute a set of 128 classification features by applying a pre-trained EO foundation model called Presto. This model basically compresses all the information captured in the time series to a handful of features particularly relevant for crop type mapping. Based on our available data, we select the crop types we want to include in the model and then train a pixel-based CutBoost classification model. The trained model is then deployed in the cloud where only you will be able to access it. As a final step, we can now apply this model to our location and season of interest to generate a fully customized crop type map. Okay, so welcome to our World Serial Custom Crop Type Notebook. After a brief introduction into the topic, you'll find an important section on how to actually run this notebook yourself. We highly advise you to make use of our Terrascope environment by clicking this link to register for a free account. After that, you will be able to click this green button to be directed to a pre-configured Python environment compatible with the World Serial system. Also, make sure that before you start, you register for a free Copernicus Dataspace ecosystem account. This will be required to generate your own crop type maps. First, we will select our area of interest. We will, for this exercise, focus on Eastern Africa. So by executing the first cell in the notebook, you'll find this interactive map widget. Simply zoom to the area of your interest, let's say northern Uganda. Switch to satellite imagery if you want to be sure to select an agricultural area, and then use this rectangular button to draw your area of interest. Next, for this area of interest, we get all the available reference data. We do this by executing the next cell. If you want to make use of private reference data, make sure to change this private extractions path. If you want to know more about how to prepare your private reference data, be sure to check out our dedicated World Serial Private Extractions notebook. Let's have a look at the results. So we found 3,800 unique samples spread across 8 unique reference data sets, one from Uganda and a few from Tanzania, also one from Kenya, for instance. And this is how the reference data looks like. So for each unique sample ID, you have information on both the actual crop type label, which is indicated by EWOC code, and then also already some time series from Sentinel-2, Sentinel-1, etc. In the next cell, you'll have the option to perform a quick quality check on the data you have extracted. You will be asked to enter a specific dataset name of the one you want to inspect. So you can simply copy one of the dataset names, execute this cell, and then paste the name of the dataset. So here you can see that we use in the backend Sentinel-2, Sentinel-1, slope and elevation from the Copernicus dam, and then precipitation and mean temperature from egg area 5 as main inputs to our crop classification models. You'll be able to inspect the percentage of node data for each individual band, also min, max, mean, and standard deviation, just to make sure that there's nothing wrong with the data you're working with. You'll also have the possibility to plot for some random samples, some NDVI curves, or any other band of interest. So now that we have our reference data, we need to select our season of interest for which we want to generate our crop type map. If you're not sure about which growing seasons occur in your region of interest, you can make use of this retrieve world serial seasons function, which will plot for your area of interest the two most dominant growing seasons. Here in this case, season 1 starts in February, ends in August, and season 2 starts in September and ends in February. Using the slider below, you will be asked to select your processing period. Note that your processing period will always consist of 12 months. Simply make sure that your season of interest is nicely centered within the selected period of time. So for instance, if we want to focus on the season going from September to February, which is centered around the month December, we can, for instance, uh, drag this slider and make sure that December 2020 is nicely in the middle. So that means that our eventual crop type map will be valid from June till May 2021. Based on the selected season, we now process our reference data to make sure that any observations not matching our season of interest are discarded. Once this is done, you will be informed about the distribution of your training data across the years. In this case, we have a nice distribution across 3 years, which ensures that our model will be relevant or useful to run across multiple years. We also see that we still have 9 unique crop types remaining in the dataset. In the next step, we will select our crop types of interest to be included in our custom crop type model. You can make use of this crop type picker application, which will show you, based on the extracted reference data, which crop types occur in your dataset and how many samples are available for each individual crop type. Simply check the boxes in front of the crop types you want to include in your model. If I would select this cereals class, then all the individual cereals classes will be merged into a single cereals class. If I, on the other hand, want to include maize and sorghum separately, I will need to check them separately. That also includes cassava, and hit apply. Once you apply this crop type picker to your training data, you will be informed about which classes are finally included. Note that all classes that you haven't selected will be grouped under other temporary crops. Now that we have our final training data, we compute our training features. Simply run this next cell and then the 128 Presto features will be computed. This is done fairly quickly, so this is how your final training data frame looks like. You have 128 Presto features and then your downstream crop type label. This will be the data frame which will be used to train your custom crop type model in the next step. After your model has been trained, you are informed about the expected accuracy based on an independent test set. As you can see here, the F1 score for maize is obviously very high because we had lots of maize samples. Other F1 scores are lower, meaning that the accuracy of these crop types will likely be less. Now that we have trained our classification model, let's deploy it to the cloud so that it's available to generate our crop type map. So if you execute the next cell, you'll be asked to enter a short name for your model. Let's say Uganda maize. Hit enter. If you haven't authenticated with your CDSE credentials recently, you will see here a link to log in with your CDSE account. If you've done so, your model will be deployed. Please note that your model will only remain in the cloud temporarily. So if you want to keep it for the longer term, make sure to download your model by clicking this link. Now we move to the final step in this notebook, and that is to generate your custom crop type map. In this cell, you will have the options to set a number of post-processing parameters. Please read carefully through the instructions if you want to know more. But for the sake of this demo, we'll immediately go to the next cell where we execute this generate map function. The function will take your custom classification model and apply it to your processing period and processing extent. So you'll notice that once you run this, your processing job will be created and start running. So in my case, crop type generation took a little less than 10 minutes. As a result, two different products were generated, one cropland mask and one crop type product. Both of them can be directly downloaded to your machine through the links provided here. The remainder of this notebook allows you to more carefully inspect these different products, and especially the last cell allows you to directly visualize your crop type map within this notebook. Of course, after download of the products, you can visualize them in any GIS software of your preference. So this concludes this demo. I hope you found it useful for your own crop type applications. Thank you for watching and see you next time. Bye bye.